So if I make a class called cat, I could instantiate several cats. In fact, I should probably call it rabbits and instantiate several of them because rabbits tend to multiply rather quickly. And which is fine in code if you need several instances of your object. Go for it. That most objects most classes we define, we intend to create several instances of them. But there's some objects that are just kind of meant to be static. In fact, we could almost go away with having a class for making a compilation unit and putting all the data members and variables inside the compilation unit, make them private and blah, 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 blah. But there's this kind of oopish or object-oriented feeling inside of us that says, well, it feels static, it kind of is static, but I still want an object. And so the design pattern to the rescue is the Singleton design pattern, which is like the first design pattern in most design patterns books. It's one of the simplest design patterns to understand. It's fairly straightforward, and that's the kind of pattern I want to use for a profiler. One profiler solves all problems. It's global to the entire game. Just say, hey, profiler, profile, 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 and it will do all the work for us. We call shutdown at the end of the game, and out pops our profiling results. Okay, well, how do we do that? It's pretty straightforward. We want to control who can instantiate the profiler. All right, does that make sense? I only want one person, or one person's a bad word for it, one class to be able to control how many instances of the profiler are created. Well, what class is the best candidate to do so? Well, that's the profiler class. So what we do here in the private section, and this code needs to exist no matter whether we're profiling or whether we're not, we make the constructor private. So I'm going to say profiler paren, and we'll just inline it here. Empty body. All right, here's the constructor. It is private. All right, now in C++ is a little different than most languages, like in C# and Java. There's all these implicit operations and things that C++ will do for you. And two of those is C++ will define a copy constructor for you automatically if you do not define one. And C++ will also define an assignment operator for you automatically if you do not define one. And so a lot of programmers think they're pretty hot stuff when they understand that and respect that rule, which is fair. You should respect that rule and be aware of that rule. But most of the time, it's not a big deal. Anyway, we need to disallow. This is called disallowing copy and assignment. You'll hear professionals say this. They'll say, oh, disallow copy and assignment. And what they mean is, again, in the private section, we want to declare a profiler copy constructor, which means it has to take a const profiler reference. Right? This is going to be the one we're going to copy from. But we don't even want to allow ourselves to copy or assign from it. If we can copy and assign, then all of a sudden chances are we'll screw up and use the copy and assignment and create a second instance of the profiler. That's the whole reason why we're disallowing copy and assignment here is we don't want anybody to accidentally use copy and or the copy constructor and or the assignment operator to create a second instance of our profiler. So we're disallowing the copy constructor like that, and then I'm going to put a semicolon here, and I will not define it. All right, if you remember, there's a difference between declaration versus definition. Right here I have declared that the copy constructor is private, but I will not define it. Thus, if I, the author of the profiler class, if I do something stupid where I would use the copy constructor and or the assignment operator, I'll get a linker error. The linker will say, hey, you're trying to use this code and it doesn't exist. What's the deal? Alright, so I'm not only guarding this class from outside users, but I'm also guarding myself by doing that. Now, we need to do the same thing with the assignment operator. Here's the syntax for the assignment operator. It returns a profiler reference, operator assignment, and then the rest is the same as the copy constructor, like so, and voila. Declaring it, but not defining it. Alright, well, this is dandy. This is good. Alright, you can't create one. Neither you nor I can copy and assign this. But we left something out. We need to actually make the instance, do we not? Does that make sense? We need to actually create the instance. We've said we're going to create one instance. We should probably do just that for the clients of our class. So that's what I'm going to do. We need to declare our instance, and I think probably the best place to do that will be right here. So let's just say profiler. You know what? Actually, I'm gonna take this out of this area and put it up here above the profiling on check here. We're going to have to, I'll just warn you up front, we will need to do a refactoring. Basically, we need to set up some configurations where when we build the engine, then not only does the code vaporize out for the profiler, but also the profiler instance itself. I want it to completely vanish away as much as possible. And I think that actually the best way to do that is to refactor this profiler logic out, and we'll do a debug library. We'll have to create a fourth project in our solution. We will have several debug tools that we will build for ourselves to use for our game, and we'll refactor this out there very quickly because we need to. And I also need to teach you about setting up, oh, not that one, build configuration manager. We have debug, we need release, and when we do release, then we want some macros defined and some not. When we go to release, we want our profiler code and all of our other debugging code to vaporize out. So anyway, but for now I'm going to put this up here, even though I'll probably eventually move it. So I've declared the instance of our profiler. I need to make it static. That's what the underline is about. The underline's like, hey, you're defining a class in terms of itself. What are you doing? So we've declared it here, but we need to define it, which means give it some room in a compilation unit. The appropriate compilation unit would be profiler.cpp. So I am going to go put it right here, which means I'm going to move this down here below our include for the header file, because the header file is where we declare this thing. So, and again, I'm going to eventually move this so it'll vaporize out, but for now I think we're good. I also need to scope it because it is a static variable. And I know this seems kind of weird that we like double declare these static variables. We put it down here, but then we also put it right here. And what are you doing, Jamie? Just go look at my C++ videos on static variables and why that's necessary. It has to do with compilation units. Those are the things that actually create room in the program image. The header file is just declarations that's saying, hey, it exists somewhere. And it actually exists right here. Okay, there's our single instance. Now that we have the one and only instance, we need to allow others outside of our class to access that instance. So doing so is pretty straightforward. We simply make a function, returns a profiler reference. We say get instance, like so. This needs to be a static function as well, so that other people can pretty much say profiler : get instance. And then of course we must define this function. So let's do that. I'm going to copy this, go over to the CPP file, and this is our right here. So then I'm going to put this right there and scope this accordingly. Profiler get instance, and in here we will return profiler. You know, I'm going to call this something else. Instead of calling it profiler, let's call it the instance. I think that kind of cues us into the fact that we're using the singleton pattern maybe a little bit more. Control-Shift-B, build started, wait for it, and static should not be, of course, because I already said it was static in the header file. Build cannot access private member. Oh, yeah, so obviously our tests, remember our tests, we wrote them against a profiler. We just created an instance in our tests like this and rolled with it, which we no longer need to create the instance because the profiler will create the instance itself. See where I'm going with that? So I'm going to delete this, but now when I hit Control-Shift-B and build, it's going to come down and say, hey, there's no profiler. Hey, there's no profiler. Hey, there's no profiler. No profiler. No. Well, guess how I'm going to solve this? Okay, I could say, well, it needs to be profiler get instance. All right, I could do that. But now What's wrong with this? It's inaccessible. Oh, did I make that private? I did. Dumb me. Let's put this in the public section for now. Again, I said we'll probably come back, refactor this, get it out of here when on a certain build. But now it's public. We should build, and so that one's okay. But no, now I got all these other ones. So maybe I should Control H and replace profiler with profiler : get instance. Profiler : get instance. Not ideal. All right, that's gonna get old. This is verbose. It's ugly. You know, I kind of just want to say profiler, and it's a singleton anyway. It's the profiler, the only profiler. Allow me to use it. So I'm going to do something that may or may not be debatable. I'm going to define a macro, and the reason why macros are dangerous is because they are extremely global, and you can go watch my preprocessor playlists if you really want to find out. We'll probably bump into some issues, but I'm going to pound define. When people say profiler, I want you, preprocessor, to replace that with profiler : get instance. Alright, so now the preprocessor will just copy paste for us. And say, alright, every time I see this, I will copy this, and I will paste it here for you. Alright, hopefully that makes sense. So anyway, let's see if it builds now. Build started. I'm glad I have those unit tests to back me up. Let's just make sure the tests are turned on. Control F5. Build succeeded. Everything's green. Feeling good about it. Good time to commit. Anyway, I think that's probably the end of this video. We got it compiling out. We have the singleton. We do have some fishy stuff here where it doesn't completely compile out. And on the note of compiling out, I also must mention, you can wrestle with this on your own, but it will only compile out if we do a release optimize build. Even in a debug build, even though I stubbed all these out, the compiler will not compile out an empty function until it's told to optimize and release. And maybe I'll do some videos on that, show you how that works. But that's another reason that we need to do build configuration manager, because right now we're building everything debug, which is fine. I mean, this is a learning project, but we really need to strip out all the extra code that the compiler adds and make it as lean as possible for actual runtime of our game. And that will require us to set up a release build. And there's all sorts of other types of builds we could do, but those are the two main ones: debug and release.